T10.12. A milk processor monitors the number of bacteria per milliliter in raw milk received at the factory. A random sample of 10 1 ml specimens of milk supplied by one producer gives the following data. Construct and interpret a 90% confidence interval for the population mean mu. Excuse me. So this question just gives us the raw data. So, prior to starting this recording, I went over to Staplet and I entered in the values here and ran the analysis, and I got the following things, which I'm now going to record in my solution. Okay. So the sample mean X bar is 4,950 with a standard deviation of 268.452 and a sample size of 10. Okay. All right. Also, kind of take a quick look at that dot plot there. I'm doing this because I'm going to close that window in a minute, but I just want you to realize that the dot plot doesn't really have any strong skewness. And as far as outliers, I mean, maybe that dot all the way on the left is an outlier, but then again, everything's kind of spread out overall anyways. Like there's just a whole lot of spread in the points. So actually, let's make a box plot. Yeah, so when I turn it into a box plot, it's not counted as an outlier. Okay, so that's very reassuring. Okay, no strong skewness, no outliers. Okay, just keep that in the back of your mind. All right, so now for our solution. So we're going to organize this. All right, the first step is to choose, right? Let's choose the procedure. We're going to do a one sample T interval for mu, a population mean. Okay. Next, we're going to define the parameter. Mu is the true mean number of bacteria per milliliter. Okay. And then our confidence level is 90%. Okay. I'm pretty sure that's all that goes in the choose step. Procedure, parameter, and confidence level. All right, next we need to check our conditions, and there's 3 to check. Number 1 is random, and let's go back to the question, and it says right here, line 2 and 3, random sample. So I'm just going to kind of quote that, random sample, check. All right. Now, the number of specimens they have is 10, right? Which is probably going to be less than 10%. Let's write it this way. 10% of all specimens. Specimens, there's an E, I think. All right, and then now what we were kind of holding on to in the back of our mind was the fact that the dot plot had no strong skewness and no outliers. And the reason why that's important is because the question stem does not mention that the population values are approximately normal and our sample size is small. So the way that we're going to satisfy that last condition is by looking at the sample data. All right, so the sample data show no strong skew or outliers. All right. So now we're going to push forward and do some calculations. All right. General formula. Point estimate plus or minus margin of error. Specific formula. X bar plus or minus T star times S over root N. Okay. Plug in the numbers now. Okay. X bar 4950 plus or minus. Okay, our critical value. Okay. Let's do some work over here on the side. Degrees of freedom. 10 minus 1 is 9. Confidence level was 90%. All right. Let's switch over to table B. Okay, 90%. Okay, darn, I got to open it up. Okay, so it was 9 degrees of freedom and 90% confidence. So we're looking at 1.833. star 1.833. Okay, let's zoom back in. 1.833 times 268.452 over the square root of 10. Okay. All right, now I know you can't see the next part because I'm just using my TI-84, so I'm doing the calculations off screen. So just kind of talk you through 4950 minus 1.833 times the 268.452 over the square root of 10. Okay, so I'm getting a lower bound of 4,794.393. And then the upper bound, just got to switch the minus sign to a plus sign now, 5,105.607. All right, finally, conclusion. Okay. So we are 90% confident that the interval from 4,794.393 to 5,105.607 captures the true mean number of bacteria per milliliter. Right? Yeah, that's it. Right. True mean number of bacteria per ml.